The Brewster F2A Buffalo, maximum speed, approximate 321 miles per hour, entered World War II as the U.S. Navy's first carrier-based monoplane fighter, promising modern performance but quickly proving outclassed in real combat. Though initially praised for its metal construction, retractable landing gear, and enclosed cockpit, it suffered from structural weaknesses, sluggish climb rate, and poor acceleration when loaded for service. Pilots struggled against more agile Japanese aircraft, forcing them to rely on energy tactics and defensive maneuvers. The Buffalo's operational history became a mix of small successes and numerous challenges. Yet it played a crucial role in shaping early war naval aviation by exposing the urgent need for better fighters. Its lessons influenced improved design philosophies, pilot training, and tactical approaches, helping pave the way for the far more capable fighters that followed. Despite its limitations, the F2A remains a landmark in naval aviation history, serving as a transition point between outdated biplane doctrine and the powerful combat aircraft that would dominate the skies later in the war. Don't forget to subscribe to the channel and support our aviation history content. Your subscription helps us create more detailed breakdowns of legendary aircraft. The Grumman F4F Wildcat, maximum speed, approximate 331 miles per hour, rose to prominence during the desperate early phases of the Pacific War, proving that rugged construction, disciplined tactics, and strong firepower could overcome seemingly superior enemy aircraft. Though slower and less maneuverable than the Zero, the Wildcat excelled through durability, heavy machine guns, and innovative teamwork maneuvers, such as the thatch weave. Pilots trusted its ability to absorb damage and return to base even after severe hits, making it a symbol of resilience in air battles over Wake Island, Midway, and Guadalcanal. Its sturdy landing gear and overall reliability made it ideal for carrier operations under harsh wartime conditions. The Wildcat helped U.S. naval aviation hold the line until newer designs arrived, buying critical time during the most uncertain months of the conflict. Its contribution to both Navy and Marine Corps missions established it as one of the foundational fighters of the American island hopping campaign. The Grumman F6F Hellcat, maximum speed, approximate 380 miles per hour, became the dominant U.S. Navy fighter of the war, combining powerful performance with forgiving handling that suited both veteran and rookie pilots. Designed specifically to outperform the Zero, it brought a 2,000-plus horsepower engine, excellent climb, high durability, and 6.50 caliber guns that delivered overwhelming firepower. During massive battles like the Philippine Sea, Hellcats achieved extraordinary kill ratios, reducing Japanese air strength to a shadow of its former power. Its range and payload flexibility enabled it to serve in roles beyond air superiority, including fighter bombing, escort missions, and combat air patrols that protected fast-moving carrier groups. The Hellcat's ability to operate reliably during long campaigns across the Pacific made it indispensable to the U.S. Navy's advancing fleet. It played a crucial part in securing air dominance that ultimately allowed American forces to strike Japan's home islands with increasing confidence and precision. The Grumman F8F Bearcat, maximum speed, approximate 455 miles per hour, arrived too late to fight in World War II, but represented the peak of piston engine fighter evolution, embodying incredible power-to-weight efficiency and unmatched climb performance. Its compact frame housed a massive R2800 engine, giving it blistering acceleration and agility that surpassed nearly all propeller-driven contemporaries. Designed for carrier operations, the Bearcat featured foldable wings, rugged gear, and short takeoff capability, ideal for fast response defense of naval task forces. Though never tested in wartime combat, it soon became a favorite among post-war squadrons and air racers due to its extraordinary performance envelope. The Bearcat demonstrated how far piston engine technology had advanced by 1945 and served as a technological bridge toward the jet age. Its legacy lives on as one of the fastest, most agile piston fighters ever produced, showcasing the final refinement of prop-driven naval combat aircraft. The Vought F4U Corsair, maximum speed, approximate 446 miles per hour, emerged as one of the most iconic fighters of the Pacific War, distinguished by its inverted gull wings, enormous propeller, and unmistakable engine roar. Its powerful double wasp engine propelled it to high speeds and climb rates that made it feared by enemy pilots and respected by allies. Initially challenging to operate from carriers, the Corsair became the Marine Corps' preferred fighter, excelling in both air-to-air combat and close air support roles across numerous island campaigns. Its versatility allowed it to carry rockets, bombs, and heavy armament, making it effective against ground targets, shipping, and enemy strongholds. As training improved and modifications were introduced, the Corsair eventually became a reliable carrier fighter as well. It produced many top aces and played a decisive role in late war battles, where its power and ruggedness helped secure American air superiority during some of the fiercest confrontations in the Pacific. The Curtiss XF15C, maximum speed, approximate 502 miles per hour with jet assistance, represented an experimental hybrid power fighter concept combining piston and jet propulsion to create a transitional aircraft for the emerging jet age. Its layout featured a radial engine in the nose paired with a jet engine in the tail, allowing it to benefit from both reliable low-speed handling and powerful high-speed performance. Though promising on paper, the project faced numerous technical challenges, including weight distribution issues, complex engine management, and difficulties integrating two propulsion systems into naval operations. Nevertheless, the XF-15C demonstrated the Navy's willingness to explore unconventional solutions during a rapidly evolving era of aerial warfare. The aircraft served as a technological stepping stone, producing valuable insights into carrier-based jet development and aerodynamic requirements at high speeds. Though it never entered production, it stands as an important experimental design that captured the transitional moment between propeller fighters and fully jet-powered carrier aircraft. The Goodyear F2G Super Corsair, maximum speed, approximate 431 miles per hour, represented an extreme high-power derivative of the classic F4U design built around the massive Pratt & Whitney R-4360 28-cylinder engine. This power plant gave the aircraft extraordinary speed, climb, and low-altitude performance, intended to intercept fast Japanese aircraft, such as potential kamikaze threats. Though the airframe was strengthened to handle immense torque and power, the war ended before the F2G could see operational service. Despite its late arrival, the Super Corsair demonstrated impressive capabilities in post-war air racing, where its raw horsepower made it a competitive favorite. The aircraft remains notable for pushing the Corsair design to its absolute limits, showcasing what piston-engine naval fighters could achieve with advanced engineering and high-output engines. Although its military role never materialized, its place in aviation history is secured by its exceptional performance and bold design philosophy. The Bell XFL Airabonita, maximum speed, approximate 376 miles per hour, emerged as a naval variant of the P-39 Airacobra concept, adapted for carrier testing but ultimately failing to meet Navy requirements. Featuring a mid-engine layout with tricycle landing gear, the Airabonita introduced several unconventional design elements for naval aviation. However, the aircraft encountered problems with structural integrity, reliability under carrier conditions, and overall performance compared to competing designs. Its unique engine placement, which granted a streamlined nose and centralized mass, offered certain handling benefits, but created maintenance and cooling challenges. While it never advanced beyond testing, the XFL contributed to the Navy's evaluation of unconventional fighter configurations and enriched understanding of what characteristics were necessary for reliable deck operations. Though overshadowed by more successful fighters, it remains a noteworthy experiment in adapting innovative Army Air Corps concepts to naval aviation needs. The Grumman XF5F Skyrocket, maximum speed, approximate 383 miles per hour, was one of the most unusual and forward-thinking fighter prototypes of its era. Featuring a twin-engine layout with the cockpit positioned well forward and no traditional nose. Designed for rapid climb and high performance, it offered exceptional visibility, impressive power, and advanced aerodynamics that reflected Grumman's bold experimentation. Although promising in flight tests, the aircraft faced developmental delays, competition from simpler single-engine fighters, and evolving wartime priorities that shifted resources away from complex prototypes. The Skyrocket nonetheless demonstrated Grumman's engineering creativity and contributed to later multi-engine aircraft concepts. Its sleek profile and futuristic appearance made it a standout example of aviation innovation, even though it never progressed to mass production. The lessons drawn from its design influenced improvements in balance, control, and power management for subsequent naval aircraft. The Grumman XF6F prototype's maximum speed. Early versions approximate 330 to 380 miles per hour, depending on engine, represented the crucial developmental stage leading to the legendary F6F Hellcat, revealing how systematic testing refined engine performance, aerodynamics, and carrier compatibility. Early prototypes evaluated different power plants, including the Wright R2600 and later the immensely powerful R2800, which ultimately unlocked the fighter's full potential. Engineers used prototype data to optimize the wing structure, adjust cockpit layout, and strengthen landing gear for demanding carrier operations. These test aircraft allowed the Navy to identify deficiencies before mass production, ensuring the final Hellcat would deliver both reliability and superior combat performance. The XF6F program highlighted the importance of rapid iteration, industrial coordination, and close communication between pilots and designers. Although the prototypes never saw combat, they were indispensable in shaping the aircraft that became one of the most successful naval fighters in history. The North American FJ-1 Fury, maximum speed, approximate 547 miles per hour, marked the Navy's entry into the jet age, transitioning from piston fighters to early turbojet-powered carrier aircraft. Its design drew from lessons of wartime aviation, yet incorporated new aerodynamic features suitable for higher speeds and jet propulsion. Though relatively limited in performance compared to later jets, it introduced carrier-compatible jet landing gear, wing folding mechanisms, and improved pilot visibility. The Fury provided invaluable operational experience, helping naval aviators adapt to the faster landing speeds, different throttle response, and unique handling characteristics of jets. As a precursor to the legendary F-86 Sabre family, the FJ-1 played a defining role in shaping post-war fighter development. Its service represented a technological turning point, bridging the gap between the propeller-driven fighters of the Pacific War and the advanced swept-wing jets that would dominate the skies in the decades ahead. If you enjoyed this detailed breakdown of iconic U.S. Navy aircraft, make sure to subscribe to the channel. Your support helps us bring even more high-quality aviation history content. Thank you for watching.